Okay, it looks like we are live, so welcome back. Today I'm going to be continuing to work on KanoScript. So let's see, so what we've got so far, I've been working on loading libraries, right, C libraries, and being able to execute the code from KanoScript. So I can show, here's an example of that. So I have this library here that I made, so this is the object file for it. So if I take a look at the actual C, the code, right, we have two functions here. We have add 10, and sub 10, so they just add 10 and sub 10, and they also print what they're doing, and they return the output, right? So it takes an integer and returns an integer. And then we have these, essentially, my mouse is dying. Shoot. This is why you need a wired mouse. Okay, then I have these, basically wrappers around it that interact with the virtual machine based on the arguments. Yeah, so I wrote these by hand, but it's going to be super easy to generate these, based on the arguments that we have, right? So that is the idea, right? So we have this, compile this to an object file, and then, yeah, we load that into here. So we specify the file name right here, then the function name, these are the arguments, and this is the return type, and then we can just call that, as though it were not really a function, but more a built-in that I have, so I have like right, that's a built-in. A function is called, like in any other language, we would call it like that. But since this way, there's a few benefits to this, which I will go over in the future. But yeah, so we can do this, and that will return 20, right? So if I run that, 20, the output is 20, and if we look at the exit code, it was 20 as well. Yeah, so that's basically what I've got. Right now, something I would like to do is actually perform some type checking, because right now, it's not checked. Yo, how you doing, Mo? What is up? Right now I can do this, and it will not complain. Right, it just treats it as a pointer, right? Well, it treats it as an integer, the pointer as an integer, so that is why it is a number like this. Which is not ideal, obviously. Even add. Alright, alright, alright. Okay, let's see. Okay, hello, welcome. So, yes, I'm working on KanoScript right now. Working on being able to call C libraries, essentially. Yeah, so as long as they are compiled to an object file, then you can link with it and then call certain functions from there. So I have this and it works. So basically, use the keyword DLL, and then you specify the object file name, and then the function. You basically define it as a function, right? Which has arguments as well as a return type. Yeah, and then you can call it like this. Yeah, so today I need to implement type checking for it, because right now it's not checked for types. Why not import? Or ref. Well, because, right, when you have one of these files, right, a KanoScript file, you can import it, right? That's importing that kind of file. But when it wouldn't really necessarily make sense to import that kind of thing. And also you need to define all of these. Like DLL, that might change the keyword for it. But I don't know that import and ref necessarily really show what it is doing, essentially. And I feel like DLL reflects that more, like dynamically loaded library, because that's really what it is. But yeah, there is a few other keywords I am considering. But yeah, I don't think import or reference or ref necessarily are the most accurate. But yeah, the syntax is not fine. So let's see, 25. Yeah. All right. So I need to just type check essentially. Which shouldn't be too hard. So it's in the when we're calling it. So that's gonna be in forest primary. Alright, it's actually under ident. And so check this. So if it is one of these, then we need to do this. So do we have the return value of it, right? We need to check basically all of that. Scenario where user misspells the keywords, will Kano catch on the issue and inform the user? Well, I think it would just say, if it is an identifier, so I'm gonna be kind of weird, but it should, the error checking is not necessarily super great right now. Let's say we put DLP instead of DLL. Let's see if that does. Don't necessarily, no, I think it'll say unexpected string. Yeah, so it says that. It says the line, the right line. So if I put, right, if everything else is valid there. then it's gonna say that. Do it like that. Right. If I run this. Yeah, it says the correct line. There's an extra new line there. I need to get rid of that. But it doesn't necessarily say what it is. Because basically it thinks that this is an identifier. So then it looks here and it's like, why is there a string there? So probably something we could do is if we have an identifier and it doesn't necessarily make sense to the next token, I can just check what keyword maybe is closest to it, something like that. For now, I'm not worried about it too much. It at least reports the correct line. Yeah. There is some other cases where it might not necessarily report the correct line. But yeah. So it's not super great at the moment. Let's see. So we have this. We'll parse these, and we need to basically check here, and then right. So there's a few other places, but here we need to check that the expression that we parse it. So let's actually make it so expr equals parse expr parser. Right, and then we have the expr here, so we want that right here. Then we need to make sure that expr type is not equal. Does not equal the func args data I. So I think that already is a type, so I think that's fine. Last time I worked on Kano was a while ago, now the code looks unrecognizable. Well, I haven't actually worked on it very much. That's probably just because it's not super well written. The code that I wrote, specifically. But yeah, I haven't really worked on it much. It is. Well, I guess there was a few changes. I don't think there's anything too major though, since last time you submitted a pull request at least. Error certification. Expected type. Type. And whoops, that's not right. Found type that, right? So I need data types. Types.data. Let me make this on a new line as well. As well as data types. Data I. And actually, that's not necessarily the right order. That one goes first because the expected type is this one. So types expr type dot data. There we go. Let's try it. Does that compile? That should be for the arguments. Pretty much all that needs to be done. Expr type. Okay. Yeah, we need expr. Is it data type or return type? Those are the data types. Let's try that. So if I run this, right, it should still work. No. Oh yeah, because that's spelled. But that should work. Okay. But then if this is anything other than an integer, it will not. Okay, so type found type void. So on line 2, 22 over. Okay, so that shows essentially where it's at. I think that is alright at least. Yeah, there is. I need to basically check. And now there are no strings basically. Because there's some issues with string that I need to work out. Right, stir and it's not data. It's not data type stir. Okay, something like that. Just a little. There we go. Yeah. So other than that, it should pretty much work. So that should be pretty much the types for that. Let me actually add something to this. Let's make maybe add two numbers, something like that. Should also print out the part that has the issue instead of just the location of the code. Right. Okay, I see. Well, that might be. Let me think. So we need basically the file, and then. Okay, yeah, I can. I should be able to. Yeah, I know what you're saying. Yeah, so I think I can just change this macro. I'm not gonna worry about that now because I'm not gonna worry too much about the errors, but I think I should be able to do that pretty much with just changing the macro. Because if we have we need to have the file name, right? But if we have that, or we have the data, basically the file data, just, you know, all of it like that, which we do have access to that, then we can just print out a certain section. We do need to know the end of it, though. So, right. That might be a little bit difficult, but I'll consider that. And there's an issue there. That's kind of yeah, I will consider that. But for now, I'm not gonna worry about it. But in the future, I will do some more stuff with on this alone. You're working on Kano and Kano. Yes, yes, indeed. Well, I'm not working on Kano at the moment, but when I work on Kano, I do use Kano. Yes. I'm gonna do A and B. So yeah, this basically add two lines. A plus B. And that to A to B. What is that? What's the current text editor you're using? Kano. Kano. It is Kano. But I'm not working on Kano, is what I mean. I'm working on Kano script, a separate project. Add. Two numbers. Okay. So A is pop, and then B is pop as well. So it takes two arguments. Okay, and then we call that on A.sn and B.sn. It's so much better. Yeah, it has it's come quite a ways. There is still, I think, some issues with the syntax highlighting, specifically when you change files like this. But that's not file that one, okay. But yeah, that's not really too big of a deal to me, at least. As long as there's some color, it's easier to look at. Yeah. And once KanoScript is ready, then I'll integrate it into Kano, and I'm gonna get back to working on Kano a lot more and stuff. But integrate that into there, and then I want to try to develop most of the new features that at least it's possible to by using KanoScript. You know, so it's basically just optional plugins for the new features, and I think that would be pretty cool. Okay, and there we go. That's pretty much all that needs to change there, I think. So let's try to compile that. So let's see. Okay, that compiled. Where can I find the macro? You mean for the KanoScript loader? I don't know exactly what you mean. You mean do you mean this macro, the print air macro, or are you talking about something different? I'm not sure it's exactly what you're talking about. No, alright, let's see if that happens. Okay. Ooh. Why does it print B first? Oh, shoot, the order is not correct. Oh, the print error. Okay. So yeah, if you open the KanoScript, here I'll put it in the chat in case you do not have going to it. You open that, and then you go to the source, and you go to this defs file, defs.h. Then we have the print error right here. So that's where you can change things. So the location, it has the row and the column, so you should be able to get the exact location in the data. And I think we have access to the data. Let's see. So if I go to, well, the parser, I guess doesn't. It probably should not be too hard to add. Let's go to the parser. So you add maybe a string here, right? And this can be file data, right? Something like that. And then we go to the, well, okay, I'll leave it for you to do that. But that's basically, I'll sort of show what to do. Because that way you won't have to pull what I have recommended. But then in the main, right, you should be able to, you read the file to view here. So you have the view. This is the whole thing. So then if you just add that to the parser, which I guess the parser is the code in here. So maybe you need to modify this parse function to just take this view here. Something like that. And then you should have access to it if you set it as a member of the parser, essentially. Then you have access to all of the data, so you can utilize that in the macro. The only thing that I'm not sure about is like knowing the exact amount to print, basically. Yeah. Other than that, it does seem fairly straightforward. Okay, yes, so the order seems to be messed up. So adding. That is interesting. Okay, I wouldn't have considered that necessarily. It does work, but the order is not right. So also, so we don't check this at the return type. I don't think we check that. Make that float. Yeah, it doesn't. Well, I guess we don't really have. Well, if we are assigning a variable, so do x equals, and then x equals, no, 15. That's not how you do that. 20. Skull. Okay. Yes. Enter float. Will that fail? There isn't no byte float. That is an issue that I have encountered. It likes to insert null bytes. And I'm not sure why I have exactly. It has something to do with the insertion, like Kano does in case. So over this, but I don't know why there's. I'll see what I can do. To be honest, it might just be easier to make KinoScript just access the file contents directly, then traverse to the file to reach the location. Then I'll just parse out the text using dot as the delimiter. Okay. Yeah, whatever you come up with. Whatever you come up with. I will get it. Whatever you think, you know? So that should be good, right? Yeah, okay. So yeah, the order is wrong, which is not great. And also it doesn't check that, so I need to get it checked at the type, but for now I want to fix the order. Have any sense on the workplace of KinoScript? Yeah, for sure. I get that. So let's see, where is that going to be? So when we call this, we're calling it, we need to check we need to set the expert return type. Yeah, so set the expert data type. So let's see if we do that. Where is the ident? So expert data type equals text func dot. Is that what it's called? It's called data type, something like that. It's not. It is pointed at it. Okay, and then maybe that should like. It is not. Okay, that is interesting. Why is it not? Really should. Okay, well, I'll come back to this. I will come back. I just want to put it out a little bit. So print it. Data types x func type dot type not dot type. Just like that. Dot data. Rather not mess with the code and maybe screw something up, I'll just add the new feature in, then later on you can just meddle with it to be properly encoded. Yeah, for sure. For sure. No. Why does that make it no? Interesting. So printing it out makes the function clear. No, that is. Oh, that is weird. Is there a valid language? I know there's gonna be a few leaks, because I don't close a lot of stuff. I can set a lot file. Kali Linux runs way faster than Ubuntu. Well, I don't know. So I've not really looked into it that much, but I think I guess Kali Linux. Well, it seems like Kali Linux would maybe be more bloated, but maybe it doesn't necessarily have many processes running in the background. Because I know that Ubuntu has a lot of that snap stuff that might slow it down a bit. But yeah, it does seem weird. Like I would think they'd be fairly comparable. Yeah. Okay. All right, we have two things there. So where is that at? It's in the run instructions, 1181. Okay, it doesn't like that. I don't think that's causing any kind of issue, so I'm not sure. I'll need to look into it. Okay, so we can do that. I just want to look at that at the moment. And that was set to a float, so that should be fine. Well, hang on, so let me go to the end here. Okay, yeah, let's go to the compilation part. And where we, gen, do not gen that. Okay, let's do, what is it going to be? It'll probably be gen expression, I suppose. Gen expert. Gen expert, let's see, expert. For X, yeah, so right here. So, we iterate over the arms. Are they appending in the wrong order? Why would that be? Oh, shoot, you know what? It's because they're backwards. They're gonna be backwards. Okay, because of the way they're on the stack. Okay, so that just means I need to change. Okay, I just need to change this. You have multiple arguments, just need to swap them around. So the first one will go last, basically. You just need to swap. Okay, that can be done in the generation stage. Then that should pretty much fix it. Let's type it out. Yeah, so yeah. Okay, if I run this now, I need 15 to 20. There we go. So that is more appropriate for the one. So now let me try to get this working, the type checking for the return type. So to come back there. Let's see. So this, and then we call this right. So let's go to say a function. Well, hang on. First of all, I want to try this. Set equal to 20.0. It will not work, right? It does work. Okay, that's not good. So I'm not checking it properly on bar yes. Yeah, so we don't check the value here. Right, okay, so let's do let's see, x-ray equals expression. Sure. Then that can be over here, expert. But when you check the data, okay, so if expert data is not equal, well shoot, I guess we don't have the variable, do we? So assign left. Well, I should do a node value dot bar dot data. Then we can print an error, yes. Error to expert location. Expected like that, but down, like that. Okay, and data types. Node value dot bar data type, as well as data type. Okay, let's see. Does that possibly compile? No. Okay, so I think I'm missing possibly a closing. That seems right. Oh, you know what? I know what happened. So right here. There we go. Okay, I just had two lines there. There we go. There was an extra closing one, which is awesome. Also, zooming does that, so I need to consider that. That is an issue. What happened here? What did this happen? Okay, try to compile that now. So node No, it's not like it. Variable. Do we have touch? Is that what it's called? Yes, okay, this again. Okay, let's try that. So we run it. Some type of input output. Okay. And then if we do the same thing, and to returns 20, and it says it returns float, which it really doesn't. But if it says that, look at that. Yeah, we don't do it like that. We do this. I should. It's not necessarily a great error message, but so you type input output. 3. Yeah, okay, so that it does report the correct location. Let's see. So it knows that it's not really a float, but it says it is. And if I change 20, it should work. Okay, 15 to 20. What is that? Okay. Yeah, so that's better now. So there is at least some type difference. I'll probably get that. And checking. Types and checking. 2. Okay. So, right, we had that. So, I don't know necessarily. I don't know necessarily that I want to get into code generation yet. But I would like to do that, right? So where you can type out just that, and then it will generate the native one. But I will get to that. I think first there was actually some more issues. So what was it? Yeah. So it was. Can't do that. Native add to nouns. So already, wait, did that? I did not call it properly. If I wrap it like this, it is still not working. So I need to figure out why that is. Right, it just grabs the last one for some reason. Spectate, yep, back. Well, no, what? That is a weird error message. I don't know what that is. Quick question. Alright. Looking into the def.h, seeing an arg called lock. Is it just a file? No, the location is, here, I can show you what it is. So I have it here, don't I? So lock is the location, basically. So lock, yeah, is lock, and it's a, it's going to be a type of this, a location, right here. Not there, it's fine. Location right here. So it just has the row, the column, and then the file name as well as container. It is a struct, yeah. It has file name, row, and column. So it's actually defined in the same file. If you just search for location, it's just called lock in the macro to make it short. That's all it is. Okay, doesn't need to tune the auto switch. I probably come up with a better answer for that. Doesn't do that. Yeah. Okay. Yeah. Well, I want to break on. Probably parse primary. Yes. And let me set this because I want to see where it actually is fit. Parse primary. So what is the token? It's an integer of 5. Why are we there? How do I compile the code? Well, you should be able to. Oops, that's not right. Let's see. It should. There's no setup, so you should be able to just do make. Does that not work? I want to run a test scenario. Let's see how the output looks like. Oh, okay. So you create a file, right? So it can be called whatever, but usually I call it .kano, right? And then you can type out. I don't have very good documentation at the moment because the language is changing. But so you can type out. Let's see. What would be a good? Maybe you could have something like write hello world. And then also you can have exit5 at the end, and then you could have something like this, right? So I'll leave it on the screen for a minute so you can set it up. But it's basically a variable declaration, making it 27. So there's some place that you could change things here to see what the output looks like to trigger an error, like put a plus there, or something like that, So if you use this, and there's a few different ways you could change it up, but that's basically what a hello world would look like. Here I can I copy that? Put it in the chat. Just so that you can copy and paste it if you want to. There we go. Yeah. Okay. Yeah. No, like again. Okay. Okay. Yeah. So that does not work, and I want to see why. Yeah. So this is why I'm seeing why. So this is type built in. That's where we're parsing this, I believe. Open dot type. Okay. So let's go through that. Built-in. So we parse the built-in. Yes. Yes. All right. Let me go through that. So that's the thing. All right. So we're good with that. Continue the next one. Let's look at this one. This should be a lock. Okay, Alec. Why is it Alec? Open parenthesis. Okay, so that is right. So then we're going to go to open parenthesis, and we have parse expert. So I want to go in there. So that is where we parse the rest. So this is where it's going to be. All right, so we have that. So this is the ident. It should find that it is in the right as an X, right? And it does. Okay. So why does it not do that? Go in here. Oh, should I press continue or not? Okay, I messed it up. I meant to do step, not continue. Let's continue to the next one. Token, and that is the open parenthesis again. Continuing to here. How do you make it run? Alright, if you type /me, or right, the executable file once you build it, and then you'd run the name of the file. And that's it. And it will run it. You can also compile it and stuff, but just to run it, you can just type out that and it will run. So yeah. Quite straightforward. Yes. Okay, so let's go here. Step into this. Sorry, I do need better documentation. Because it's not very good at the moment. But I don't want to write a bunch of stuff and then it becomes instantly outdated and I have to change it. Yes. No, it's getting close to where I'm pretty happy with the syntax for most things. So I probably will start writing it pretty soon. Okay, so we parse the expression. So what gets parsed here? What is this token? Type is int token dot integer is 15. Okay. Return out of there. Then we are back here. So we check the data type, and that's fine. We append that to there. Let's see. So appends that. I want to think. So why is it going to be? Oh, but does it end there? Is that what the issue is? It's 2. Okay, so it's not. So let's go there. It should parse this next one as well, which should be 30. Dot integer 30. Okay, get to the end here. That is fine. Alright, it's 1 now, so we can exit out of there. Return there. I did not mean to continue, so that probably messed everything up. What is this one? Yeah, probably exit. The exit. X, yeah. Okay, so we don't have what the value is. Okay, so I need to start it over again. A lot of slashes in the. What's the point of that? Alright, let me see. I'm assuming. Right, I'm assuming. If you mean these slashes, that is to indicate that it is a line break in the macro, right? So if you have a macro, they can only be 1 line. But if you do this, it allows you to write it on a continuous line. Because otherwise it'd be like define, assert, whatever, do if, but this way you can do a slash, and that allows you to go on to the next line as well. That's all it is, if that's what you're talking about. Okay, let's go there. So I want to, so this is what gets parsed. Why did it do that? Okay, let's swim back here. Yes, that's what it is. Yes. They could be more even. I suppose I could run like a format or something to that actually like aligns that. But I'm not done. Alright, so it is that, yeah. So that is fine. Print, well, so we get the exponent, but then when we parse it, right, so that's 15, so that's fine. It's 30, so that's right. But for some reason, that gets returned. I don't know why that is. So we get to the end there. We don't have expr anymore. Print expr value next. Expr value next dot args x dot args dot data 0 dot data 0 dot value. Dot value dot integer. Okay, so this that data 1 dot value dot integer is 30. Okay, I'm gonna print token 0. So the top token is close print. Okay, so why is it gonna be 30? What is going to cause that? Type is no, expert type is that. Okay, let's go out of here. Then we should be back here. Okay, so print expert type x for x. Okay, so that is right. So why does it not call the functions? That's in the generation stage then. Alright, so that is alright. So let's maybe run it again. And click on gen expression. Yes. Alright, so the first one is going to be the built-in. So we don't need to necessarily, well, maybe it's not. Okay. Print name. So generate all this, but then we don't actually call it. Gen expert. Okay. Print expert x dot args dot data 0. So it's still 15. Alright, so generate all that. That is fine. Do it again. Push the integer. Okay. Then we get to the end and we do this. Gen, yes, we gen the native. Okay. Why do we do this? This is for, okay, because it's to make sure it's the right one. Oh, but we never generate that. Okay. Okay, so we have an issue with that. Right. Alright, so that's what it is. It's not generating this stage for some reason. Which I think I might know why. So the built-in. That is interesting. So where do we set that? Let me go here. I think it's in here. Depending to there, we can do that. But we don't actually that in. Well, we should. Right. Because we parse it. Let's break on parse expression. Let me see why this does not get appended. Right. So if I go, well, I wanted to break on parse primary. Let's see. So this token is the built-in. Yes. Okay. So the built-in DLL. We parse the built-in node, but why does that not add it to the thing? Right, so what about moving it outside of this changes that? State next. And so here's where we append it, but we never called this. Which is interesting. So that's in gen built-in. Why don't we call it? It does call it. Okay, so why is it not appended then? Is it called after? Oh, shoot. Ooh, okay. I see, I see. So I understand what happened basically. So this gets parsed, this gets generated before because it's a global variable. So I need to generate those first. So the x. Right. Okay. I did not consider that. Right, so right here. We need to, I guess we need to basically append it first. Right, but then we don't know what it all is necessarily. Right. So basically this gets generated first because it is generated. We passed the value. Okay. So that should be, yeah, that should work as long as I append it before. So if I do it in the parsing, which really makes more sense anyway. So if I append it in there, so we have basically the list of x's in the parse, right? So parse to next parse x. And let me just make sure that it's what it's called. So let's go here and let's go to the program state. And that's actually not fine here. It is in here. X numbers. Okay, so I guess that's what it's called. X numbers. Sure. Alternatively, I guess we have the symbol table. We have access to it. But I actually don't. But I should be able to add that. Right, something like that. Which makes a lot of sense to have anyway. Symbol, right. Symbols. Okay, so if we have that, then we can set it in here, right? So the state.symbols equals program.symbols. Right, so if I do that, we should have access to it. So let's try to apply that. And program has no memory of symbols. Okay, program does not have it. Why not? The parser has it though. Okay. We don't have the parser. That is not great. Let's see. Program. Let me look at that. So program, that should have a pointer to the browser. It's stuff that should be anyway. And we can set the program at the end. I guess maybe a conflict because reference to it would not necessarily work. Considering exact. But that makes sense. So if we have that, or alternatively, right, what are we getting here? We need the cursor dot. If I do that, have it in the program, then we can access it from the program. So that could work. Okay. So going all the way through that, then try that. Right, symbols is unknown. That is not good. Let's make it a pointer to it, and then I can just strip, right? Do that. And just point it at it. It is the program that doesn't like it, right? Okay. So if I do that, and then yeah, it can't be a pointer. Okay, that's not gonna work because it's not allocated. So it needs to be. What if we define things? What if I move all of this up here? Will that work, or is it? Is there stuff that is? There shouldn't be. Well, the symbols out and stuff. And you move all this up, okay? But then there's other issues with that. So might not work. Alright, let me just try. But I think those things are defined after, so. Symbol. Yeah, it's to not be a pointer. Okay, that actually did work. I'm kind of surprised. But let's see. So that will work then. So now we should have access to the symbols in here, which is what I wanted in the first place. So then we can just basically look it up in there. So not symbol, but rather yeah, right here. So instead of doing this, we don't really need to do that. So I will get rid of that for now. I don't want to get rid of it entirely. So right here, instead we can iterate over the symbols dot count. Then if symbols dot data I equals symbol x and that. Okay, then if we go here, segment. Okay, don't know why it's segment. Let's see. We'll just show where it's segment. Okay, so it doesn't like that. So let me break in back in .c 498. Right, yes. Now I can look this up. So print state segment dot count. State segment dot data I got type. Is that okay? Oh shoot, I see what the issue is. Okay. Minecraft server protocol is kind of bad. Not really surprised. I hear a lot of stuff with Minecraft. Like the stuff behind it, the code, is not great. This is clearly the issue. Symbols data I dot name. We have a name. I don't know. No, so let me look at the symbol perhaps. That is not what I wanted to do. Let's see, I'll just go over here. Symbol dot x dot name. Okay, that's what I need to do. They change it like every major version too, so there's barely any documentation on any version. Wow, okay. Why would they change it entirely every version? That's kind of weird. Okay. Val. Okay, dot val. Then we do that, and if we run it, same code again. Alright. And where? Let's see where. In run instructions. Okay, 1165. So it's trying to call it, and it doesn't work. So is there an issue? Oh, shoot. Okay. Now this I thing is not working. So that's not great. Okay. So I guess. this I can just do work around at least for now. So let's do X count. 0. So I want to out here. And then state symbols data I equals symbol X. Then X count plus. And actually I'll even do this. Otherwise, we'll just continue on, right? And we don't have to check this condition here. I'll do that, and then we use count x2. If I do that, it should call the variable. So it does not. Okay, let me just let's see. Is it? It might be just +1 since we do that. I wonder if GDB if it's so it does not. Okay. No, yes. Trace. Same place. Okay. Let's maybe we'll break on 502. Well, let's take out 500. Let's see 500 and run it again. And take a look. So X count becomes that. Okay. But we have not pushed it yet. But do we have to? We do have to. Okay, so this whole thing isn't going to work anyway. So I need to... that's not great. I need to basically generate it beforehand, but I don't necessarily have it already. So that is unfortunate. Right, so that's not going to work regardless. Alright, that is an interesting thing. So, to fix that, wait, this is like a scoping issue, basically. We need to generate it first, right? Pretty straightforward, but we don't have it, so... if we append it to the X, if that is the type, right? I guess that is what we'll do. So we have these for the first set nodes on X. X nodes, right? We'll append to that. Something like that. And then if we encounter one of them in here in particle thing, so if node value dot expert state dot value dot value dot x no dot type rather equals extra x. Then we want to append to arena parser x nodes and then else we'll do the rate. Do that. Okay, if I do that, does that actually make sure that will compile? Does not. So parser is dot x node. Yeah, so I need to add that to the user parser. Alright, that is a pointer, so that's also not right. Why is that not right? Hang on. Okay, it's up. It's in here. Pulse. Okay, and then right here. Like that. Okay, so that'll work. So if we check that, we'll come into this one. Then we need to generate those first of all, before anything else. For let's iterate it here. I think some state. Ooh, we need to set it as well. I forgot about that. I'll do it after exit. Actually, it'd be program. So program interface. Dot chat. Plus plus. And just built in program interface dot data I. Basically something like that. I'm not sure exactly, but something along those lines. Let me look at that. It's a state and expression. So that's not really an expression. Dot ANI dot value dot X. The value dot something. I don't remember exactly. Whoops. The value dot expert statement. Okay. Expert statement. Okay, so if we do that, then we should have right. They should be generated. But I do need to add to the floating point. Okay, so in the parser, right? Parser we have X nodes. That's what we want to call it. So program X nodes. There we go. All right, we need to set it as well. Copy it over this thing. Okay, and exit the file. This I bumped it. Okay. I'm assuming it's going in the same place. Yeah. Okay. So I'm going to quit that and then run it again. This time break on. I think it's what it's called. Yes. And let's see. So does it generate? That's not what I want to break. I want to break on generate. Yeah. Start it over. Okay. All right. There's 0 of them. That is interesting. So why is there 0? Does this not get okay, so click on 1153 front end.c 3. We get to that point. We do. And we do not. Wait. Yeah, we do. Okay. Expert state. Clear state dot type. Expert built in. Oh shoot! So it's an expert built in. Right. Okay. I need it to not be that. So what is so node value dot expert dot value. Node value expert statement dot value is that, and then the value dot built in dot type, right? Yeah, so I did the wrong thing. So let's go in dot type equals yeah, that's what I meant to check next. Right, so when we're loading ADL like that, built in, value dot built in. Okay. Still cycles. Dang. And in the same place, I'm assuming. Yes. Okay. So let's go back here. dot C three run. Okay, now yes. And let's see, print node value dot expert statement dot value dot value statement dot value. Shoot, because we didn't set it yet. Node value expert statement dot value dot value is built in DLL. So we did do that. Okay, let me think. So type equals that, then we append it there. So we break on generate and continue. That's one. Okay, gen built in. So do all that. Still does not work. So let me break now. Let's go to backend.c and let's go to gen expression. Gen expression. I want to see this one. So I'm gonna go here basically. So break on 494. Okay, so right here, print name, print state symbols. Okay. State symbols. Okay. It's 2. Okay. And let's see. So we generate that, and then we go here. Next. Yeah. He's currently 0. That makes sense. State symbol. Data is that okay? That makes sense. State symbols. Data I. Hang on. Data I dot now dot x. Alright, that is the name. So it is 30, so it's just to the end there. So that should be fine. Alright, one, so that is where it's wrong. It needs to be +1, not +2. Unless we just iterate at the end, and I think that would make sense anyway. Right, then we can still do the +2, and it should work. Okay, index out of range, so it almost worked. Almost worked. So we cannot access this variable now. Why is that? Right, getting rid of that though. It did work in that case. Now when we exit with X, I access the variable properly. That is let me try something. So I said X equals 57, right? Do that. Then it does what? It does 57. Okay, so it's just specifically with that. Let's see, 15 and 30. Right. Okay, index out of range. So I need to look at. Let me actually commit this in. Okay, generate X functions properly on global variables. Now cannot access the variable application. So that's fine. Okay, so why would that be? So parse the expression. It does grab it properly. So maybe let me Tim, and I want to go build tire. I want to disassemble. Oh, actually, I need to build it first. It's actually on bottom. Tim build tire. This So that is the whole code. So we do these, and we call stack size push 15. Right. So I wonder. I'm assuming it's the. What would it be? Maybe 2. She consumed 2 of them. Well, hang on. So 15 and 30. Am I not? Well, okay. The expert value. Let me think. So is the stack size going to be off then doing that? Right. But what would be index out of bounds, right? So -1. I'm trying to think, like, what would cause that? Halt. Push 0. Well, let me look mark through it. So we push a string. The side has a string on the side. Another string. We get the stack size, so it'd be a 2 currently, right? Push 15, push 30. -2 will consume. So we don't ever push the native though. Is interesting. So yeah, we don't ever do this. Oh shoot, because we don't handle that instruction. So I added new instruction, but I did not add it to the dissimilar. So that's why it does not show it. So this one actually works. So I need to add that. Need to add that as a to do. I'll just put it here because it's not actually officially in it. So that's gonna cause some weird problem. But let me do. Let's see. This assemble does not. This does not recognize the node library instruction. Okay, yeah, so I need to fix that. I need to fix that. But yes, you can imagine that would be there, which would actually consume what do you consider all of those? I'm assuming those. Actually, this might be overlooked, so I don't think we push the sex action. So we have 15 and 30 then. We call it -2, which will consume both of them. Right, well, it should consume both of them. And then why is it? Alright, it says halt. So actually, maybe this isn't a good way to do it. Maybe I should just run it in GDB. Then break on run instructions. I feel like I'll get a better idea there. Right. Because it's a bit outdated, which is unfortunate. Let me actually move that. No, but that makes sense. Break on run instructions and run with that. Okay. Then it will look nicer. Okay, so we load those two natives. Go here. So let me display machine instructions data IP dot type. So we push theirs. We push the string first. Right, so that's pushing like all of the data, right? Push the entire string. And then push another string. So the data for that. This one's actually gonna be a bit longer. And then we load the library. So this is where we load it. So we pop, and then we pop again for the lib name. So that should be fine. We open it. Did not want to step into this though. Alright, and then if not lib, then we put an error. We do have the lib, so that's fine. We do that. We go there. Okay. This next one is push. Okay, so we're pushing onto the stack. So what is the machine instructions? Data IP is 15. Okay, so that makes sense. So we're pushing 15. Let me look at the code as well. We have 15 and 30. That will be push. So the next one will be a push as well. And yeah, so it is for 30. So then, yeah, then we should call the thing, I think. Yes, we're calling the native. So let's maybe step into that even. Can I? We can't actually see it because it is a native like that. So, but it did work. Then we call stack size. Okay. Then we do actually get stack size. So this is what we're trying to get. So let's print. Print. Machine stack size. We have that. Stack size. Whoops. Stack size is 1. Okay. 1, 1. So we push the stack size. Then machine instructions data IP dot value is 0. Okay, push 0. Then we subtract. We subtract 0 from 1, right? Machine dot stack. Dot stack 0. Okay. And now we're doing an index loop. So what index we get? Index is 1. State static size. And, not state. Machine static size is 1. Okay. Trying to do that, but that is too much. Index iterate. So why is it iterate though? I don't get that necessarily. Is it because of something here? Well, hang on. So let's see. So we call the built-in, right? Here, we subtracted incorrectly here. Maybe I'll print this out. State static size. So before and after. And it should be -2. Two, and then it becomes 0. So, but we do not account for pushing things on the stack. So that's the issue. Right, when we generate this, it will push onto the stack. So we need to look at the return value of it. If state no, if expert x return, I gotta remember return type. It's not equal type void, and state stack size plus 1. So that I believe is the issue. Oh yeah, I'm just gonna click after that. Let's see. Is it data type perhaps? No. So what's it called? Text. Return type. Is that not what I put? Next font column. That's the wrong one. Ooh, we don't set the return type. Okay, we need that. We need to set that. So that's the compile number, we don't actually set it. So that's going to be set in here. What is it? So we need to set the return type to that. So type with type. Okay, basically pass it over, right? Okay, next, and there we go. Okay, the exit value is correct. Okay, is this NeoVim? No, this is my own text editor that I made. It is called Kano. Kano right here. If you want to see it, it's very it's heavily inspired by NeoVim, we'll say. But yes, it is not. TKS. I do not know what that means. Oh, thanks. Okay. Yes. Okay. I've not heard that one before. That makes sense. Let's see. So that seemed to have worked. Okay. I think yeah. So that was something that I that I wanted to get done. So that's good. Check for the type generating oh, push that. That's pretty good. So we can call to that. And should be able to call in here as well. And we can. Okay. Okay. 30, and I can change this so if I get 20, 30, 50, right? Okay. Seems to work. Seems to work. Seems to be working. Seems to be twerking. Alright. So yeah, should be able to link with any library. The only issue is we don't generate the code properly. So that is sort of what we need to do now. Not right now. I'm going to do it on the next stream. But I need to generate the code so that we can interact with it. Because right now we have this. So we can define a function, but then we have to create a wrapper around the function. So like we have here, where we'll call the function, and it will also interact with the virtual machine to pop and push things onto the stack based on the arguments taken in and the arguments going down. So that is necessary to do. So, but obviously it's really easy to generate these. So that's what's, you're gonna provide the function, and then we'll look at the function name. We can generate that easy. We'll look at the argument values, right? And we will create things like this that pop it off, and get the value of it. And then we're also gonna check to make sure it's the proper type and things like that. I just don't do that here. Yeah, but it's super easy. It's just like if a type is not equal type int or whatever type you specify, then right, we can do that. It's basically just all the same. So we pop it off based on how many arguments. You just pop off again and again. So B, C, things like that. And then you create a variable of whatever type with the result, and you call the function with all the arguments. And then yeah, you need to create a word like this to wrap it up. Essentially, you can also just do it as a one-liner, and I'll probably do that. Which I think you like it. So word like that. Okay, if I do that. Yeah, so just called word in that case. But then, yeah, then I short it, right? No, just called result, yeah. Then still, yeah. Okay, so that, it'll look something like that. But yeah, obviously it's very easy to generate. It's all like the same. Yeah, and then should be able to link with essentially any C library. Just link with it, and then based on the, you need to create the wrappers for it in the language like this. But yeah, this gives all the information we should need to generate that. Right, so ideally you specify like that. Add two nodes, and it will generate this native function, and we call it that. Yeah, okay. So that is the plan for the next stream. But now, for now, I have to go. So that is gonna be about it for today. So let's make sure that all worked. All right, that's good. So thank you guys for watching, and I'll see you next time.